Ready? Is it going? Okay, so I think that there is a confusion, right? The relationship of plan to form is a crucial thing in architecture. What you do in plan impacts the form. What you do in form impacts the plan. As a matter of fact, what you do in plan affects section, what you do in section affects plan, what you do in form affects both. Many of you in this past between Tuesday and today, Thursday, did not take that into account. So today, I'm going to ask you to relook at the offices and labs, correlating plan to section and plan to form. Okay? You are to use all of the standard drawing conventions, which is heavy lines, thin lines, dashed lines. Each of those things means something in architecture, right? And there can be two kinds of dash lines. There can be long dashes and short dashes. Okay? So when you guys are working on your plan and your three-dimensional sketched form, I'm going to ask you to think about the two together and to think about the section. I am going to ask to make sure that you guys are always considering human scale in what you're doing. I want you to start with your offices first. Okay? So is that clear? Do we understand that? Okay. Now, in regards to the manipulations that you're doing with your offices or your labs, I want to put some delimiters on, because as I walked around, I saw a lot of kind of craziness going on, right? I saw a lot of, I'm going to approach this like it's an arch101 project and do all this stuff. Let's analyze this logically, okay? If I have a laboratory that is 20 feet by 30 feet, and then I have another one right next to it, okay, then what we're most concerned with is what's occurring on the outer edge, because what's occurring between these two is a mechanical space. Okay, that's a space, right? It's a mechanical area. It's kind of like the rooftop of this building. It's not pretty. Okay, so you're really not going to have doors and windows or any kind of outdoor space that's in that area. Okay, I'll do another one here just for the heck of it. This is not a pretty area, correct? Now, if this happens to be facing, if north is that direction, I'm going to put it a little bit of an angle like that. Is there something pretty out this way?
Yeah.
Yeah. There's an ocean out there. There's a beach. There's good-looking boys and pretty girls or something, right? There's bicyclists wearing spandex. Roadies. Correct. All right, let's rein this in.
Those are the
All right?
views, Biggie.
So
That's views of the site.
So what I'm asking you to deal with is right here. The other place that you can deal with things is what occurs at this end, which is where the corridor goes through and where you might access the front of your laboratory or the front of your office. Okay? So I want to make sure that that's clear to you guys when you're doing this. Okay? Is that understood? Yeah? Okay. Now the next thing that I want you guys to do is I want to put some limitations on what you can do with the front of that, because I just saw some wild kind of arch101 stuff. Okay? So you are allowed to either slice back so that the front wall leans away from you, or slice forward so that the wall leans towards you. So in sort of sectional view or in profile view, you're allowed to do this, or you are allowed to do that. Okay, let me put a little person in here. All right, so do you guys understand that?
Mhm.
Okay, so in all cases, I want you guys to leave between 2 and 4 feet of flat area on one or the other. Okay, so this is another criteria that I'm putting in for you. The angle back, I'm not going to worry too much about now, but let's just say that it can be somewhere between 10 and 30 degrees. Please don't do a 45-degree angle. Okay, so 30 degrees, in case you are having a hard time visualizing that, is like this. Let me see how close I am to 30. Damn, that's pretty darn good, isn't it? Let's see this one. Yeah, damn, that's pretty good. Wow, what skills, what mad skills, right?
Yeah, your hand was twisting.
Huh?
It's like kind of fixing the triangle.
Oh, come on, really?
Oh,
Uh-oh.
challenge accepted.
Look, that line's uneven.
Oh my God. Brian, Brian.
Okay, we gotta keep going. We gotta keep going. I disagree with you, Brian, but I promise I won't fail you for it. Oh, okay, all right. So, do we understand that limitation? Okay, one of the things that I tried to teach you guys in Design 1, and you were supposed to learn it again in Design 2, was the idea that you don't just arbitrarily decide, I'm going to do that partway across. I think I'll do it to about, I don't know, something like right here. The idea that architecture is in some way linked to geometry is important. And so you guys are supposed to be thinking in terms of, hey, this thing has a halfway point, right? 1/2 and 1/2. Now that's perfect symmetry. Daddy don't like perfect symmetry, but it is logical, correct?
Yeah.
All right. And actually, no, I mean, if you think about it, if you were to slant a portion of this to the halfway point, right, it would create an asymmetrical elevation. Is that right?
Mhm.
So there's no problem there. No problem whatsoever. But in addition to that, there's also third points. There is also quarter points. Right? All of those. Do you guys remember when you guys were in Design 1 and you immediately wanted to do, watch. I don't know if the camera can pick this up, but symmetry! 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 Right? Let's see if it goes this way. So it's like, no think, symmetry! Symmetry! Right? Knee-jerk reaction? When it's like the doctor in it, it's like, why are you doing symmetry? Well, I don't know, it just seems organized. Correct? Remember that? Most of you, not all, but most of you were my students in Design 1. And you heard me rant and rave about knee-jerk reactions with no thought. Does this not also imply order? Just like symmetry? So if you like symmetry for that reason, you should absolutely like this. Guess what? It works in all 3 dimensions. Right? It works vertically. It works back and forth. It's like magic. Just like symmetry, right? It's magic. But it's a little bit more complex. It's a little more, commensurate to a college student rather than a, second grader. Okay? All right. So that's another thing that I'm going to ask you guys to do is to think about why and where you're deciding on where you're putting these lines. Okay? All right. I would like to, so I've already limited you to 10 to 30 degrees here. Right? 10 to 30. We'll take pictures of this and maybe just make a handout of it. All right? So I've already told you that you could go all the way across, you can go halfway, you can go third, right? Yes? All right. So after you do that, I need you to do one other thing. And actually, you know what? I'm going to draw a line right here because I think it probably should have a flat part at the top and a flat part at the bottom too. But not necessarily. I guess it doesn't have to. Okay? So I want you to focus on this and focus on, you know, one of doing a cut like that, or it could come all the way down, or it could go all the way up, but it should have a flat part somewhere. Okay? Look at these two diagrams. These are good diagrams to look at. Why would you do a spatial subtraction? So here's this lab. Why would we ever think of doing a spatial subtraction here? What's out here?
The ocean.
Oh, the roadie bicyclists, right? Right? Roadies, beach. So why would we do, let's just assume these are offices instead of labs. Why would we do a subtraction? Give me a functional reason for doing a subtraction. Whoa. The Cuban says something. Go ahead, Cuban.
Porch or balcony? The porch or balcony?
A balcony. Do you guys like to work in rooms that have no windows and no access to the outdoors?
No.
You don't, do you? Okay, so might this researcher enjoy having a small balcony? Maybe?
Yes, I would.
Okay, all right. So after you've done your sort of morphing by angle, you can decide if you want to do a subtraction on this side, or if you want to do a subtraction in the angle. Me understand.
Working hard.
Oh, that's right. In design 1, we put in this cutout because it was the entry porch. I remember that. It creates a recess that becomes an outdoor space in my volume, right? Okay, so the next thing that I want you guys to understand is that this angle and either this subtraction, right, or that subtraction, either one is going to have an impact on what you see here, okay? So, for example, if I go with that subtraction, I'm going to see something in plan that might look like this, right? Now, what kind of line do I use here? Oh, a light line, maybe something like that. Okay, how do I show, let's forget this part. How do I show that angled piece that goes back? Oh, well, there's a dashed line somewhere over in here. Right?
Yeah.
Okay, now, what I'm doing here is having an impact on what's happening there. Did I tell you guys that you were allowed to put in some sort of a mezzanine inside the labs?
In the lab, no.
Yeah, in the lab, as a matter of fact, I have the drawing right here. As proof that I did discuss this the other day, I have the drawing here, and I have these dashed lines going across. I believe you will find it in the recording also. I did say that if you wanted to, you could have a mezzanine, and we could just, again, we're not studying laboratories as a typology, we're using laboratories as a vehicle for understanding and expressing architecture of some sort of a technological or machine sort of character. Okay? All right. So
Big stuff.